Hello, people. My name is Satyajit Mohanty, and I'll be introducing you to this course on basic cryptography. So let's proceed. What does cryptography deal with? Secure communication between two parties when a third party is present. The third party is generally called as the adversary in this case. Cryptography deals with data confidentiality, data secrecy, and in cases of certain authentications, cryptography is implemented. Cryptography involves modern mathematics, computer science, electrical engineering, and communication science. In this particular lecture, we'll just have a brief idea about what cryptography actually is, and we'll not go into it in detail because it involves some kind of mathematical congruences which is out of the scope of this lecture. All right. What are the different processes in cryptography? Cryptography includes encryption and decryption. So, what is encryption? In layman's terms, is the process of translating it into one's language, which no one else understands. And decryption is the process of understanding that message in the new language. So, we will do some basic encryption and decryption stuff in this elementary example. So, this is a Caesar cipher, and this Caesar cipher is one of the first cryptographic systems in the modern world. Cipher, you can see this plain text. Let me point it out to you. You can see this plain text and the cipher text. So what happens is basically each plain text element, that is an alphabet, has a corresponding ciphertext alphabet. So suppose there is a message like hi. So hi will correspond to its ciphertext element, that's LM, and so and so. So this hypertext element can be anything. For example, I have just shown you it from D to C in a sequential order. It may also be from M to L or from Z to Y, whatever you may choose. That depends upon you. And you may also choose it non-sequentially, like random J, S, A, Y, whatever sequence. It doesn't matter at all. So using this Caesar cipher, we can encrypt and decrypt certain messages and then transmit the encrypted message so that uh, this cryptographic function will work. So let's consider a particular example. Suppose the message is Caesar was great. So using this Caesar cipher, we can encrypt this message by replacing its plain text elements with its corresponding ciphertext elements. So C here becomes F, as you can see right here. A here becomes D, which becomes T right here. So this whole message out here, Caesar was great, this becomes this message, this encoded message. And this encoded message is not intelligible by a normal person. It won't be. And when this message reaches the receiver, and when the receiver has this particular plain text and ciphertext arrangement, then he'll be able to decipher this particular message into the original one. Um, Caesar cipher, in this particular example, we see that this follows this particular congruence relation. C is congruent to P plus 3 modulo 26. And in other cases, like if we started from some other number, like since we have started it from D, so since there is a gap of 3 between A and D, so this therefore this relation is 3 here. If we started from B, then this will be 1, and so on. This is random sequence. This, if the ciphertext is arranged in a random manner, then there will be no such congruence relations per se. And the C and P are the decimal equivalent of the alphabets, like A corresponds to 0, B corresponds to 1, Z corresponds to 25, and so on. Elementary example of Caesar cipher will proceed to a more sophisticated kind of cryptography. This cryptography has been used since many a long times, because it's efficient and it contains it is more efficient than the previous kinds of replacement ciphers. So what happens is this: in a room, there are three people. Name them Keshab, Sanskar, and Satyajit. Have to take their names to give them credit for giving me such an idea of a test lecture video. Keshab and Sanskar, thanks for this. Sorry, Om. Next time you will definitely be in this credits. So, suppose in this situation, Keshav wants to share some secret information with Sanskar, which he doesn't want to, which he doesn't want anyone else to know, not even Satyajit. Okay. So, suppose the only means of communication is Keshav writing something on a piece of paper and then throwing it towards Sanskar. That's the only means of communication. Today's generation contains all this WhatsApp and this messaging and all, but back in old days, when people used to send messages from one place to other place, they used to do it by sending letters or mails and other stuff. So when a particular message gets transmitted from one place to other people might also be able to see that message, and that is unwanted. So the main question here is how to transmit a message such that only the sender and the receiver can get it and read it, and not a single other person from the intermediaries will be able to decrypt it. So so in this situation, if the only means of communication is Keshav writing something on a piece of paper and then throwing it towards Sanskar, then if Keshav does so, suppose in that room there are three people, and in that room if Keshav does so, that means if he throws the paper containing some piece of information towards Sanskar, and if Satyajit catches the paper when it's in midair, then problem, because Satyajit will be able to read the message and the secret is revealed. So what shall Keshav do in such a scenario? This is the main question. So we will be implementing a logical analysis about this. So consider this as a unlocked box, right? This box is unlocked. Anyone can open it if it is unlocked. There are three people in the room: Keshav here, Satyajit here, and Sanskar here. Keshav wants to pass some information from him to Sanskar such that Satyajit won't be able to access it, right? So what Keshav do is, if this is a hypothetical situation, if Keshav puts his piece of information on this box, means he writes that information on a piece of paper and then he folds it and then he puts it in the box, and if he doesn't lock the box, and if he tries to send the box to Sanskar, like throwing it midair as described, then if he tries to intercept it, then he'll succeed because the box is unlocked. Satyajit may catch it midair, and then Satyajit gets the message and the secret is revealed. So Keshav was unable to transmit his message to Sanskar without getting it noticed by me. So in this case, what would Keshav do is Keshav would lock on this box. And this red lock is put by Keshav. Let's imagine that. So Keshav has a red color key also with him. So when Keshav puts a red colored lock or a lock on this box, and when he transmits this to Sanskar, right here, then when Satyajit tries to um, mediate, then he won't be able to access the box because the box is locked. Box is locked, and Satyajit won't be able to access the box. So Satyajit failed to access the box. On the other hand, since the box is locked, so Sanskar at this moment also won't be able to access the box. So then that's a problem because Sanskar needs to get the information. So what would Sanskar do here is Sanskar would put a different lock on this box, say a blue lock. Will put a different blue colored lock here, and what he'll do is he'll throw that same box midair to Keshav. So this happens, and here Satyajit also wants to interfere or also wants to meddle in and mediate and access the box, and he tries it. But since the box is locked, so Satyajit is unable to access the information, and Satyajit is not happy. So the box with two locks now reaches Keshav. See, the Keshav has initially put a red lock, and the key of that lock is with Keshav. Keshav doesn't send the key to Sanskar because if Satyajit also catches the key, then he'll also unlock the box. So Keshav has his own key, Sanskar has his own key. They have kept their keys separately with them only. Now the box is with Keshav. So what Keshav does here is, with his red key, he opens his red lock like this, and we have this. And then Keshav throws this box to Sanskar midair, or transmits this locked box to Sanskar. And Satyajit also has felony. He also tries to access this particular information, but able to access that message because that message is locked. That message is encrypted. And then what happens is this particular message reaches Sanskar, and Sanskar, having his own blue key, he opens that blue lock like this. And now Sanskar has that box, and now Sanskar can open that box and can get that particular information. And in this whole process, Satyajit didn't get any chance, and he couldn't access that message. So that message successfully got transmitted from Keshav to Sanskar without any interference of any third person or any adversary. In that case, is Satyajit or me. You can see Keshav is happy with that, Sanskar is happy with that, and Satyajit is sad that he is unable to do anything. So such kinds of information generally works in basic cases, but in advanced cryptography, we don't use such piggy bank cryptographic systems and scissor ciphers because those can now be easily cracked through high superpower machines, computers, and all. So far we have learned about the term cryptography, how things can be encrypted and decrypted through physical means, and how the basic principle works. In future, we'll see there are various kinds of cryptographic terms and methods such as public key, private key, symmetric, asymmetric, RSA encryption, 256-bit encryption, etc. Those involve high level of mathematics, calculus, linear algebra, which is a prerequisite for this course. And if you are not comfortable with such things, then please do revisit those mathematical concepts before pursuing cryptography. um, as I said, to study those, we need to go deep into mathematical aspects of it, try number theory, congruences, the quadratic reciprocity law. Those are important for cryptography. And if people take interest in learning more about such methods and terms, I'll definitely make one more lecture for your kind interest and cooperation.